Acid rain is caused by reactions in the environment. Nature depends on balance, and although some rain is naturally acidic, with a pH level of around 5.0, human activities have made it worse. Normal precipitation, such as rain, sleet, or snow, reacts with alkaline chemicals or non-acidic materials that can be found in the air, soils, bedrock, lakes, and streams. These reactions usually neutralize natural acids. However, if precipitation becomes too acidic, these materials may not be able to neutralize natural acids. Over the time, these neutralizing materials can be washed away by acid rain. Damage to crops, trees, lakes, rivers, and structures can result. Acid rain is caused by certain types of pollution that release carbon, sulfur dioxide, and other similar particles into the air. These particles mix with water vapor and give it an acidic quality that continues as the water vapor is gathered into clouds and eventually falls as rain. What effect can acid rain have on architectural materials? Let's investigate using a few common construction materials. This is acid rain. Some of the greatest damage from acid rain occurs to man-made structures. You can see these effects on many structures in Washington, D.C. The acid interacts with some of the stone and eats it away. Over time, details and artistry are worn away. For this investigation, you will need a pH sensor, SparkView software, a rinse bottle, a large cup with 100 milliliters of water, 3 beakers each with 50 milliliters of vinegar, an iron nail, limestone, granite samples, and a straw. For the first part of the investigation, we're going to use a beaker with 100 milliliters of water, a straw, and a pH sensor. So let's turn on our pH sensor. Okay, I see the Bluetooth flashing red, letting me know it's ready to pair. I'm going to click on sensor data and connect. And I see that my pH sensor has the ID as 703. It's reading the same here, so I'm good to go. Once you get here, you're going to want to click on the digits display and make sure that you're reading the pH value. All right, so let's see what the pH of the water is right now. Click start. And it's about, give it a second. About 9.35, it's hovering around this, letting me know that it's a base. Okay, I'm going to stop. So next, we're going to blow into the beaker using the straw for about 60 seconds, and we'll speed this up for you, and then we're going to check pH again. All right, let's check our pH now. I'm going to start again. Interesting. Had a bit of a decrease. Wonder what caused the pH of the water to change. I'm going to stop recording. Pull out my sensor. All right, for the second part, we have our 3 beakers with our severe acid rain substitute, also known as vinegar. So let's check and see what the pH of the acidic rain substitute is at the start. I have a cup here and a rinse bottle, so I'm just going to give it a quick rinse with some distilled water. And get that into my beaker. I'll click start. Much different than the water. Looking around 2.19. Hovering around there, definitely acidic. Okay, going to give this a quick rinse again. Set it off to the side. All right, so next I'm placing the nail, the limestone, and the granite samples into the beakers. And we need to observe over the next 5 minutes any notes, any reactions that we may see, and then we're going to test the pH after those 5 minutes. We'll speed up this part for you. Okay, so we've done our 5 minutes and doing some observations right here. Looking at the nail, I see some bubbles on it, and it's actually starting to change color a bit. My limestone is really bubbling. There's something definitely going on there. And the granite sample, not so much. So let's check the pH of each of these and see if we can find anything interesting. All right. Okay, let's try the nail first. We're reading at 1.82. Okay, rinse that off. Now let's check the limestone. Looks like it's still thinking here. pH is going up. Still going up. Okay, about 3.2, 3.3, hovering around there. That's pretty interesting. Stop. Rinse one more time. And let's see what's going on with the granite. Interesting. This one's leveling out pretty quick. We're looking at 2.19. Okay, so that wraps up our data collection. For the analysis portion of this investigation, you will refer back to your observations and pH readings to answer the questions on the student sheet.